In part one of my videos on graphing lines in slope-intercept form, I talked about how to use the y-intercept and rise over run of that y equals mx plus b form to graph our line. And we talked about how m was the slope, that kind of told us where to go using rise over run, and b was the y-intercept. Now, the one thing we didn't talk about was, well, what if you have a line that's not in slope-intercept form, like this first example right here, 3x plus 2y equals 10. And the idea, some of you may have figured this out on your own, will be to get it into slope-intercept form by isolating the y. So we're going to isolate or solve this for a specific variable, which is y. So to do that, I have to look over here first on the left side. I'm trying to isolate the y. So I've got to figure out what is over here with the y that needs to move first. And in this case, it's going to be the 3x. That's the furthest thing from the y on this side. So I'm going to subtract 3x from both sides. Now, you may be used to doing this way, and there's nothing wrong with this. You might write this as 10 minus 3x. Remember, this is not 7x. We cannot combine 10 and negative 3x because they're not like terms. You may be used to writing it this way, and I'll do this for the first one just to show you. And then if we divide by 2, we've got to divide by 2 to each piece over here. So this would be y is equal to 5 minus 3 over 2x. And this answer is not wrong. We could totally graph it this way. But on a lot of multiple choice tests, you probably wouldn't see this answer. They would write it so it looked a little bit more like slope-intercept form, where they write the mx part first and the b part second. So let's go ahead and just kind of rearrange this. Since this 3 over 2x is negative, I'm going to put that first. I'm going to put y equals negative 3 over 2x plus, and since that 5 is positive, I'm going to put a plus 5. So again, maybe a better way to write this, not that this is incorrect, it's good to understand that these are actually the same line, but a way you would probably see this on a multiple choice test is as y equals negative 3 over 2x plus 5. Now, just like we did previously, let's graph this. So remember that the plus 5 means that we need to start up at 5, that's the y-intercept. We've got to start up at 5 on the y-axis. So 1, 2, 3, 4, 5. We're going to put a dot. And from that point, this negative 3 over 2 tells me the rise over run. And you should be able to tell from this one that we are going down 3. You remember what we did in the last video. And over 2. Okay. Again, I can repeat this pattern if I'd like. Down 3 over 2. I could go up 1, 2, 3, and backwards 2. Again, that's all in the same line. As long as my line, since that's a negative slope, as long as my line is going downhill from left to right, I know that I've got the right direction here. Sorry if you can hear the train in the background. Okay, so that'll graph the first line for us. Notice that we had to get it so the y was isolated first, so it looked like slope-intercept form. Okay, now we'll get to this next one. Same idea. The y is not isolated, so let's start by getting it there first. Again, the furthest thing from the y on the left side is this negative 3x. I'm going to have to add it now since that's negative to the other side. All right, so I'll bring down, that'll cancel. We'll be left with 6y equals. Now again, 3 and 3x are not like terms. Okay. When we do that, we're going to have to write this. And I'm actually going to do this, unlike the last one, I'm just going to start off by putting the 3x part first. Since it's positive, I'll keep it positive. And since that 3 is positive, I'll put a plus 3. Okay, that way I get it closer to slope-intercept form right away. Now what I'm going to do next here is divide by 6 through each of these. So I'm going to get y is equal to 1/2 x plus 1/2. Now, this one is a little bit trickier to graph because we actually have a starting point here. Our y-intercept is a number that is halfway between two different numbers. So if we start here almost in the middle of these two, if I'm going to graph this, I've got to rise 1. So I'm starting in the middle. I got to go up to the middle, but go over 2 and stay in the middle. I got to go up 1 and over 2 and stay in the middle. And this is totally fine to graph this. Some people might like this trick. Your teacher may not really care which way you graph it. But another way to write 1/2, we could actually write this as the complex fraction 1/2 over 1, meaning going up 1 and over 2 is the same as rising 1/2 and running 1. So watch what I can actually do here. If I go up 1/2 and over 1, that actually puts you on a nice even point there. Notice how that all lines up. Or, again, I could go down 1/2 and back 1. And then from there, I can start going down 1 and back 2 again, and it all kind of lines up. Again, if that doesn't make sense to you, that's fine. That's just another nice little nifty way to graph this that keeps you on even points sometimes. And that would be our line there. So again, isolate the y first, and then graph the line. Okay, getting there. Let's go ahead, and I'm going to skip this one just to save time. Let's go with this last one. If we have x minus 2 is equal to 3, let's go ahead and start by isolating. In this case, I don't have a y, but you should be thinking right away that since there's not an x and a y, this is going to be a special type of line. We'll see if you remember which one it is here in a second. Is it going to be horizontal or vertical? Now, in this case, since my only variable here is the x, I'm going to isolate the x. If it were just a y, the same rule would apply. So here I'm going to isolate the x, and I'm going to get x is equal to 5. Now, again, this isn't technically slope-intercept form, but the same rules apply. Once the x is by itself, you have to remember here that if we cut an x in half, it makes a v for vertical, telling us that this is going to be a vertical line that crosses through the x-axis at 5. So I'm going to go out to 5. 1, 2, 3, 4, 5. And I'm just going to go straight up and down here. Okay. Go straight up and down, and that should be our graph here for that one. Again, these are a little bit different because they don't have y's in them, so you're not really isolating y. But if there's only an x, that's what you're going to be isolating for those. Okay, so again, the idea here, if we flip back an example, would be first step, isolate the y, make sure the y is by itself. Only then are you allowed to graph it using your rise over run and your starting point, which is your y-intercept.